By the way, the date is not correct. It is the date that I gave the slides to. It was today, 3 days ago, 3 days ago or something. Okay, don't worry. It will be a simple talk, I think, an easy one. I'm not clever enough to just invent difficult things. I'll start with the teaser here. Ceci n'est pas une pipe is a famous painting from René Magritte. And in fact, what is it? Well, what do you see? Well, you see maybe a picture of a pipe. Maybe you see a slide describing a picture, describing a pipe. Anyway, and it's a teaser, and I will come back to that later, right? Okay, let's talk about programs and computations. First of all, I'm going to use the word programming computation in a specific way. And in fact, computations are monads, okay? Just an idea how many people here know what a monad is, just to give some idea. So, okay, I'm good. And in fact, they are, like Eugenio Moggi said, they are kind of computations, okay? So I'm going to talk about programs versus computations in a certain way. And so a program, say, think of it as a potentially effectful function abstraction, okay? In the same way, a computation, I think about it as a monad. I think about it as a potentially effectful expression abstraction. For me, there are a lot of discussions for programmers who are using monads. It's difficult, but in my opinion, it's just a potentially effectful expression abstraction. And by the way, I was one of the people who were already well, part of this whole monad movement in the 90s of the previous century. I had some papers on monad transformers and stuff like that at that moment. Just to give you some idea, at the University of Utrecht, where the guy who just left also worked. Okay. I think, well, they're both kind of combinator-like things, so they're both can be seen as components, but I would like to show you the difference between what I call open or closed components. And the best way is maybe to do that via the associativity law. In the sense that if APB stands for a program, whatever it is, so, but anyway, I will come to that later. I've already gave you a little bit an idea about it. That takes an initial value of type A, so to speak, and transforms that maybe while doing some effectful stuff in the middle to a final value of type B. That's APB. And if I compose that with BPC, like this, and then afterwards I'm composing the result with CPD, I guess I don't have to explain that. That's just the associativity law, right? Let's compare that with the associativity law of monads, of computations. That's this one, okay? Now, I'm going to do both back. Now, you all know about monads. How many people can think they can reproduce the associativity law for programs? Maybe not with exactly the same syntax. I think everybody can. But how many people frankly say like, okay, just give me and I will write it down on the blackboard, the associativity law of monads. Okay? It's different, right? Just to give you again a teaser, okay? So it's about the difference between complexity and difficulty. I think that programs are less complex than computations. So if you really think about it, there must abstractions of functions. So functions are, in my opinion, also less complex than expressions. Okay? And let's agree that too much complexity becomes difficult for human beings. Not for computers, but for human beings, right? Many times being confronted with complexity isn't fun, right? Programs are perhaps more difficult than computations at first sight, but I will come back to that later. And next thing, once and for all, understanding that difficulty, isn't that fun? Okay. So it's a little bit of promotional talk for not fixing too much on monads, although I was one of the first persons working on it, but anyway. Okay. Denotational versus operational. Programs are denotational artifacts. A function also. A function can be given a meaningful name, right? Programs can also be given a meaningful name. Computations, just like expressions, are operational artifacts in a way, okay? So they are evaluated to yield a value. Computations are executed to yield a value, maybe performing some side effects along the way. And I think that, but that's a personal opinion, that thinking denotational is more natural for human beings. So let's talk about my library now. It's a program specification-based programming library. It's not a language. How many people have heard about FP, this programming system of Jan Backus, who presented that during his Turing Award lecture long time ago? Yeah, okay, some too. Well, it's comparable to that, but first of all, that was a language which is less flexible than a library. It didn't deal with effects, and well, we'll see, but it's very similar to that, okay? And in fact, it was more like a language implementation, and I would really insist on writing specification here. It can be seen as a domain-specific language for the theory of programming domain. You know, when you're writing software, it's for from some domain like finance or insurance or whatever. And so you're going to write interfaces for that kind of specify the essence of that domain, okay? And that brings me to the other bill. It can be seen as a programming course for Lean itself. So I'm learning Lean, what program is all about, so to speak. But that's what you do with mathematics also, if you learn Lean, what a group is, or what a category is, or whatever is, okay? It comes with documentation. I will show you the URL. That I'm going to present here, but I changed to Lean just because of its proof assistance capabilities. Okay, and that's happened quite recently, so it's really still work in progress. What does PSBP support? Well, point-free programming, just like the FP system of Backus. This is an important one. Positional programming. Well, the opposite of point-free programming, let's call that point-full programming, where we have values. I don't even want to use the name variables, because there are even some languages that are talking about immutable variables, which I don't understand. Let's just talk about values. But positional programming is very akin to, it's kind of point-free, point-full programming. And it's typically used for scripting-like programs that kind of combine maybe other programs in a little script like a main program, which is typically sequentially, it's like a recipe. You start with some ingredients, the first do this, then do that, and at the end you have a cake, okay? And so positional programming, in fact, is not needed to use that positional programming, but it's more convenient, it's more elegant. Programming is also about elegance, right? And it goes even as far as also showing what is happening behind the scenes. You can also see, like, the positions are in fact positions on a runtime stack. And you can show that stack just by, instead of showing the results, showing the complete computation. So it shows the whole history, which is interesting from an educational point of view, I think. And of course, also effectful, it's an effectful system, right? So effectful, I mean, maybe changing internal state in a pure functional way, or I/O, whatever, external state, so to speak. It's work in progress. I do have a lot of similar work in Haskell, and some people may know Scala as well, in Scala as well. In fact, most work is I've been doing in Scala, because I did Scala professionally before I was retired, but I changed back to my first love, Haskell, and then I left it for Lean. So all contributions are welcome. I will show the GitHub repo. Okay, let's start. Fibonacci. Don't worry about the first lines, but it seems to be a program that is transforming an initial value of type nat to a final value of type nat. And you see this if thing here. Think of it as a library level keyword. And if the initial value is 0, the final value is 1. If the initial value is 1, then the final value is also 1. I don't know if you're acquainted to those dollar symbols, but that's to avoid how they call parentheses. It looks fine with parentheses as well. And then I'm constructing, with the and symbol there, I'm constructing 2 intermediate values. The first one is by first subtracting 2 from the original and then letting Fibonacci do its job. Okay, you see. And then those 2 intermediate values are added. So the beauty of the code is what you don't see. I don't see any immutable variables, okay? I don't see any values. Well, beauty, it's, of course, I agree, I totally agree, is a subjective notion. But there is another thing. Do you see this unsafe here? So for all safety, it doesn't compile, right? And maybe with, maybe with this partial thing you have been talking about, and optionals and stuff like that, there are solutions maybe to do better than this. But anyway, once I'm implementing this, because now I'm going back to my pipe, this is not a program. It's a specification of a program. Okay? And a specification of a program is a kind of description of a program. See what I mean? Just like that pipe, that painting is a description of a pipe. That's why I had this first piece. And if I'm implementing that, and I'll show there are many ways to implement that, and that's also the beauty of it, you just choose your implementation. Then, of course, well, luckily enough, Lean does produce code. And in fact, not a week before now, I had to change my code because of the new compiler. That did some optimizations, and not for my code, but I changed my code so that it did the optimizations for my codes to actually, optimizations or whatever, did some magic to produce code. Now, what are the things here? Functional, sequential, creational, and conditional. That are, of course, the type classes that I'm using, and I'm going to explain them. So I'm in the context of programs that require some functional, sequential, creational, and conditional type classes. Okay. Factorial is similar, and in fact, if you switch, you see it's not that much difference. But I only have the 0. And I have only one intermediate value, the -1 factorial, right? And then you see this identity. So I'm actually keeping my initial argument, which is different from normal composition. If you do normal composition, then your first value, excuse me, I'm keeping my initial value as an intermediate value still, okay? And if you do normal composition, your initial value is lost. Okay, so you can think of this here, this combination of a pairing, so to speak, and identity as defining a local immutable variable. Okay, and then of course you just multiply them instead of adding them. Now, from now on, I'm going to talk about values. But again, all the identifiers that I'm using are meaningful. There's no identifier may be a part of those operators, I guess, but that makes sense. And if, of course, I could also replace it by product, but then I don't have that nice infix syntax. Okay, I can even introduce a let to kind of show that, well, it's really like a let. It's this is an intermediate value. Okay, gonna prove. So then Fibonacci and for they are not programs, the program specifications, and compare this with a painting. By abuse of language, I'm gonna use program instead of program specification. So let me start with an abref. Maybe I should use a dev, but anyway. And the reason why I do that is just to distinguish functions that are part of my API and really the notion of a function as opposed to the notion of a program. So what does functional mean? If I have two types, then functions, well, there is a way to let functions be used as a program. Okay, so the last line, and you see there, I use that arrow for, that's part of the API, but functions, I want to emphasize that, okay? So there is a way to use functions as a program. Well, we are talking about functional programming, right? Okay, function from A to B can be used as an effect-free program from A to B. Again, from abuse of language, I'm not going to say type A from an A to a B, okay? Sequential, that's what you all know, okay? Just if I can go from A to B and from B to C, then I can go from A to B. So it's all simple, right? I guess most of you just saying, like, what is this guy talking about? But anyway. Then a functorial, what I call functorial, functions can act on programs. So that means if I have a program that was potentially effectful, then I can still let the function do something with the result of it. Okay, maybe multiply it by 2, which is typically used for parser combinators in combination with what I will show now. So a function can, in an effect-free way, on the result of an effectful program. Okay. And of course, why? Because if you have parsed two things, then you may want to maybe combine them, maybe by appending 2 strings or something. See what I mean? And that's effect-free. So therefore, I call this is a sequential product. I do that because I will show. Now I'm specifying things. So nothing prevents me to also specify. I didn't implement anything parallel products, for example. So it's extendable, while FP, the language of Bacchus, was not extendable. Fantasy is the limit, but of course, it's kind of aggressive programming. Oh, I specify everything, but of course, in the end, you have to implement it. Okay. Conditional, well, it's kind of the dual of a product. If from a C I can produce an A, and from a B, then from a C or a B I can also produce an A. Many of you may think and know about arrows. I don't know. And here it's what I presented so far is very similar to arrows, but my notion of choice is different. This is different. And as a consequence, for example, which I will show in a minute, error handling will just be dealing with, well, error handling can have 2 results, the normal result or another one, and can be processed by this afterwards for error handling. Okay. Parallel, that's what I said. Why not just 2 programs in parallel from A to C, B to D, then from A and B to C and D? There's another thing. The type doesn't tell the implementation, because The sequential and the parallel thing, they can be, as far as types are concerned, can be defined in terms of each other. But I think at programming level, it makes sense to distinguish them. So to consider parallelism as a specification thing, not as an implementation thing. Oh, now I'm going to do all pairing in parallel. No, you should say, okay, I want to do these things in parallel and the other one sequential. Okay, so programs can be combined in parallel. And that's my parallel Fibonacci with one extra thing here. And in fact, that is the one with the signature of the sequential one. So, okay, I have to, there is some choice of operator names, but there's nothing to do about that. Ah, and the difference was, of course, okay, yeah, okay, that's true. No, there should be a kind of, I think I forgot a bit, I forgot a parallel here for the simple reason that I do copy paste. Sorry for that. I have to change. Now, implementations, okay, and I'm going to continue. You can do that synchronously, asynchronously, whatever. Reactive, using continuations or callback handlers. And I've defined my own reactive type T here. Asynchronous, sorry, the parallel ones I use task. I would love to have an actor library in Lean that does it in a better way, I think, and so on. Cannot state, restate, write state, but then just as programs. Implementation, just I use the state T. Failure, like I said, failure will just, this is just an API, fail with a function. It could be a program if you wish, but I don't think that you have to do effects during handling your error. That also turns whatever A into an exception. And I implemented just, like I said, as a sum. Okay. Oh, by the way, I forgot to tell you, and sorry for that, but because I see I don't have enough time. Of course, I'm implementing things as computation valued functions, Kleisli thing, right? Kleisli, I don't know. And that's basically it. I'm not going to, first failure with a monad, accumulating failure with an applicative and a monoid. Now I'm using monad and stuff like that. So it's the whole thing, but at specification level, and it's your freedom to justify whatever you want. There's a GitHub repository, which is there, and stuff like that. And I have other ones, a Yoneda thing. Some people interested could look at it. And time hybrids, which is really an interesting program, and which I've already written in Scala, which I want to port to Lean as well, and all contributions are welcome. Okay. And so thanks for listening.